Assalamu alaikum. My name is Nafiz Mahmood Shaun and my ID number is 240037. Today I shall be presenting the basics of Zener diodes along with a brief overview of diodes in general. Let's begin by understanding what a diode is and how it functions in electronic circuits. What is Zener diode? You can see the definition here. In shortly, we all know that normal diode conduct current in forward bias, but in reverse bias it didn't. But Zener diode is a kind of diode which conduct current in forward bias and also in reverse bias. And it's a special type of semiconductor diode designed to operate in the reverse breakdown region of its voltage current characteristic curve. Unlike regular diodes, which are damaged when reverse voltage exceeds their breakdown limit, Zener diodes are engineered to safely conduct current in reverse bias in a specific voltage, which we call Zener voltage when it raised. Zener diode is a kind of diode. So when in forward bias, genetic characteristics is same to same normal PN junction diode, but in reverse bias, if the current didn't pass through the normal diode, but in Zener diode it passed the current in reverse bias. Zener diode didn't only do current conduct but also do one thing, which is voltage regulate. It's mean in the Zener diode areas it maintain a constant voltage, which mean whatever you change in the circuit, Zener diode make a constant voltage in the area zone, across zone. Also one thing, it is not like that in reverse bias the Zener diode started to conduct current. It is actually in reverse bias exact value of voltage on the upper limit of voltage. If we give only that time, Zener diode start the current conduction like this. From this Zener diode characteristic curve, we can find that how much voltage the reverse bias need to conduct current in Zener diode. While already we said that it's actually in reverse bias exact value of voltage, which is Zener voltage actually on the upper side or the voltage limit or the upper limit actually, and then the Zener diode start the current conduction, and you can see that in this graph. Actually is the limit or maybe the upper limit. That's how the Zener diode characteristic graph is worked. Points to be noted. First one, in forward bias it acts like a normal PN junction diode, and two, in reverse bias it conducts current when the voltage across it is equal to or greater than Zener voltage. It regulates the voltage across it, which is equal to the Zener voltage also. If voltage across Zener diode equal to V applied, Zener diode will conduct for V applied greater than or equal to Vz, which is Zener voltage of voltage, and Zener diode will regulate Vz. Vz means voltage of Zener diode, whatever V applied is beyond Vz. So let's take Zener voltage 20 volt and we give Zener voltage across, we give 30 volt. The Zener diode activated by the 30 volt, true, but its across voltage we won't get 30 volt, we actually get 20 volt because Zener voltage is 20 volt. Here is the voltage Zener voltage, which is 20 volt. In PN junction, for the forward bias case, we all know that when a normal diode is forwarded bias, it replaced by a voltage source whose value is diodes. which values diodes built-in material potential equal value, like silicon or germanium, whatever is the material is. And in reverse bias, normal circuit replaced, here is this normal circuit replaced by open circuit. Here is the open circuit because no current is conduct actually. Later we find that. In pin junctions diode, in Zener case of forward bias, again same. We all know that a normal diode is in forward bias, it replaced by a voltage, and for forward case in pin junction diode, it will be replaced by Zener voltage source, which is value is diode's built-in material. Like if we use silicon, the voltage should be for silicon 0.7 volt or germanium 0.3 volt, whatever with the material actually used in that case. And in reverse case, there is two conditions: when applied voltage is less than Zener voltage and when Zener voltage is greater than applied voltage. If the case is applied voltage less than Zener voltage, then normal circuit replaced by open circuit because no current is flowing. Yeah, here is this. But if the second case, it will not be replaced by any open circuit because in that time reverse bias conduct the current. It will also not replaced by the short circuit. In that case, it's reversed by generator. It will actually reverse. In that case, reverse bias generator replaced by a voltage source which is equivalent to Zener voltage or VZ. Like whatever I am saying is there. The Zener voltage case, V equal to built-in potential of the diode material. And there is the two conditions, whatever I already told you. There is the open circuit if applied voltage greater than Zener voltage, and if not or exactly different, then the whole things will be the bias reverse bias generator will replace by voltage source which is equivalent to Zener voltage or VZ. Here is the. Now let's take a math example. Determine IZ and IL for the circuit. Here is the first circuit A and second circuit B. In this circuit, no effect in Zener diode. Find the voltage if the directional. We can find the voltage differences in this terminal by using VDR. In this two terminal voltage means 1.2 ohm across voltage. Now use VDR and find the voltage for the first A. And by doing this math for first A VL, here is you can see everything here, and the others mathematics terms is here equal IZ plus IL, and then IFZ equal to. Actually, when you come here from this terminal in this thing, it will be replaced by actually the voltage difference in the terminal is nothing, 0, so we can use direct in this way, and here is nothing to say, which is when you did a math, which is 8.727 2 volt, which is less than 10 volt. 10 volt means here is the VZ, Zener voltage actually. So Zener diode replaced by open circuit. In this case, open circuit, open current value 0 also. When you found the open circuit, it will be the current will also be 0, must be. And in the second B or second chart, in this case again we do the same math using VDR. We found the voltage VL equal to 12 volt, which is greater than the VZ 10 volt. So in that case we need to find out the current. For this reason we have done these things. You can see that I got IZ plus IL, then IZ, then I and IL. After this we can do the math and we will find out IZ equal to I minus IL. So 6 ampere minus 3.33 ampere. What we find in there, IL equal to 10 minus 0 divided by 3, and we found 3.33 ampere. And that's how we do the math. Thank you so much. Assalamu alaikum.